Assalamualaikum and hi to Dr. Azmin. My name is Muhammad Azim bin Zulkifli. My metric number is 203244. So I will start this presentation with a little bit of introduction to our project. So basically, wind energy or wind power is known as the process of generating mechanical power using wind. The generator in a wind turbines can capture moving wind and convert it into supplies of electric current. So basically, the wind turbine use kinetic energy and convert it to electrical energy. Wind turbine is basically like a fan, but it is the inverse of a fan, which is wind turbine use wind to produce electrical energy, but fan use electrical energy to produce wind. So there are four main parts of wind turbine, which is the rotor, the blades, the nacelle, and the tower. The nacelle contains of gearbox, low high speed shaft, generator, controller, and brake. So there are two types of wind turbine, which the first one is horizontal axis wind turbine. The rotating axis of the blade is parallel to the wind turbine. One of the example of HAWT is upwind and downwind wind turbine. Next is vertical axis wind turbine. The blades of the vertical axis wind turbine rotate with respect to the vertical axis that are perpendicular to the ground. So there are two examples of this wind turbine, which is Darius turbine and gyro mill turbine.
Hello, my name is Harish and my matrix number is 203140. Today I would like to present about the objectives and the recommendations of the project. So let's start with the objectives. So these are our objectives for the project. So by doing this project, we are able to repolish our CATIA, the engineering drawing tool, because we have to present a 3D drawing model, and this kind of project improves our fluid mechanics knowledge and the general knowledge, of course. So we feel like this kind of project should be given to students in order to encourage their participants and to improve their knowledge as well. So next, my friend would continue the presentation. Thank you.
So hi everyone. So I will be presenting the conception of the system. So my name is Lim Jyoti. My matrix number is 203245. In this part, they will be divided into 5 little parts. And without further ado, I will start with the first one, which is wind. So what is wind? Wind is the movement of air caused by the uneven heating of the earth by the sun. So it is a very amazing thing, which is it's strong enough to sail a ship across the wide ocean and even tear down a tree on the ground. The change of atmosphere pressure generates wind. So in general, the wind blows from high pressure into areas of low pressure. Next is wind zones. There are 5 major wind zones around the world. Okay, first of all, so polar stellites are dry, cold, prevailing winds that blow from the east. The second one, westerlies. Prevailing winds that blow from the west at the middle latitudes between 30 and 60 degree latitudes. Hot latitudes are a narrow zone of warm, dry climates between westerlies and the trade winds. So trade winds are powerful and permanent east to west prevailing winds. This wind is quite common, which we encounter it many times, which is capable in developing tropical storms, including hurricanes, cyclones, and typhoons. Last but not least, doldrums, the area where the northeast and southeast trade winds converge, which is called the Intertropical Convergence Zone, ITCZ. Okay, now I move to the third part, which is the energy of the wind. So to know the amount of energy of wind transfer to the rotor, it depends on the density of air and the rotor area. So first of all, density of air, which is kinetic energy equal to half mv squared, which means the kinetic energy is proportional to its mass. So density of the air is rho equal to mv. So this means that the kinetic energy in the wind depends on the density. The amount of rotor area determines how much energy a wind turbine is able to harvest from the wind. As for the next, which is Band's law. In 1990, German physicist Albert Benz published this law, indicating that the maximum power that can be extracted from the wind is independent of the design of a wind turbine in an open flow. So, according to Benz law, no wind turbine can capture more than 59.3% of kinetic energy in wind. Albert Benz came up with one equation, which is the ratio between the power extracted from the wind and the power in the undisturbed wind. Okay, so now we move to the last part, which is power of the wind. P equal to half rho v cubed pi r squared. So we are able to calculate the power of wind passing perpendicularly through a circular area. So now I have explained my part, which is the conception of the system. Now I will pass to the next speaker to explain how does a wind turbine work. Thank you.
Okay, so now I'll explain to you how does a wind turbine works. So first, kinetic energy from the moving air, which is wind, blow into the wind turbine rotor blades. Then, the kinetic energy from the wind makes the rotor spin and the center drive shaft turn to support them. After that, the gearbox inside the nacelle converts the low speed rotation of the drive into a high speed rotation so fast enough to start the generator efficiently. The generator then converts the kinetic energy from the spinning drive shaft into electrical energy. After that, the wind speed and direction are measured by the anemometers and wind vanes. The measurement collected is then used so that the wind turbine can face directly toward an oncoming wind and captures the maximum amount of energy.
So thank you, my friend, about the clarification about this research. So moving on to my parts. My parts is about 3D model design. So before we start, I introduce my name is Razlan Birazwan and my matrix number is 203139. So for today, I will explain more about the comparison between common wind turbine with our new prototype of wind turbine. So moving on to my first point. My first point is about the common wind turbines. So for the common wind turbine, we can see over here, this is a common wind turbine blades. So today I will explain more about the characteristic of the common wind turbine blade. So the first one, as you can see at this blade, it has a flat and straight blade which is less efficient to the air resistance. Number 2, it has too much drags and less efficient also to the air resistance, and it will generate rotation power, very less power, and the construct for these blades are cheaper and easier to construct, and the design for the blades are less aerodynamic profile, which giving a poor lift to the air resistance. So the second point, okay, as you can see over here, this is our new prototype of wind turbine. So I have designed this new prototype of wind turbine using a SketchUp. So I will explain more about the characteristic of these blades. So the first one, the blades are now slightly curved and allow the blade to move faster than compared to the common one. Second one is the blades can generate more power and high efficiency towards to the air resistance, and then it can be higher lift result in the greater power during the rotation, and for the manufacturing for these blades it may be cost and complicated for its design, but it's better and improvise the aerodynamics over here, or we can call aerodynamic profile, which is give higher lift and rotates the turbine more efficiency towards the air resistance. So my third point is about the orthographic of the blades. So as you can see, I have designed this blade with a cone shape, and for the wing flag I have designed using the half parabola, and also the diameter for this drawing is equal to 1 to 1. So the next is the orthographic of the wind turbine. So this is a model that we create and we design for the new prototype. So that's all from me, and I will pass to my friend. Thank you.
Hi, my name is Nur Faris Aiman bin Nuraimi. My matrix number is 203243. And now, I will explain about the wind turbine efficiency. The picture shows the free body diagram of wind turbine in a wind tunnel. We set the wind tunnel as the control volume, and air flow from one end of the tunnel to another end at a certain velocity, Vmax. The black curvature line shows the air flow going through the wind turbine. The wind turbine is fixed, hence it exerted force T to oppose the wind turbine. The air is slowed down and goes around the disc. That's why it is a curvature line. The equation let us calculate the value of force T in order to get maximum energy from the wind. Beck's limit shows the energy that we can extract from wind kinetic energy, which is only 59.3% of the energy. The extract kinetic energy then will convert into electrical energy. Next, we will look on assumption of the wind turbine. In order to get the maximum wind kinetic energy, we have to look at some factors. First is the location of the wind turbine. Second, the blades of the wind turbine. Last but not least, the height of the wind turbine. For the location, it must be windy and far from civilian, as it can make a loud noise. Next is the blades. For the blades, we have to look at the numbers of the blades and the shape, because for the number of the blades, we have to look at the cost to make each blades and how efficient the number of blades can affect. And last but not least, the height. The height is because we want to have the air velocity at a highest velocity. That's all from me. Thank you.
So now I would like to talk about the recommendations and especially on the shape of the blades. As we all know, the traditional blade type is the flat blade, which is very easy to construct and much more less cost compared to the modern blades because it has the aerodynamic profile and it is more efficient. So technically it needs more engineering knowledge and analysis to construct it. And the modern blades have a better angle of attack, and most of the time the wind angle should be taken into the consideration while designing it. So the design of the turbine blade can be improved further by using a twisted and tapered propeller type rotor blades. This is because it has a better drag reductions and of course it will have a better efficiency. So these are some images regarding the recommendation. So we can see here where it doesn't have a twist blade. This is the twist blade. So these are some of the advantages of using the twist and tapered blade. So this kind of blade can be taken into consideration while building a next turbine blade to have a better efficiency. So that's all from my part. Thank you.
Assalamualaikum. So I will continue with the part of recommendation. So my name is Nurul Hani Shafika binti Rosani and my matrix number is 203142. So one of the recommendation is the number of blades. So we go with 3 blades. This is because the angular momentum is stay constant when one blade is up and another 2 is at an angle. So the wind turbine can rotate smoothly. The fewer number of blades, the greater suited system is for producing power. Even though I say this, there's come with issue when the wind turbine is lesser than 3 blades. For example, 1 blades would be an optimum number when it comes to energy yield. However, it will make the wind turbine unbalanced, so it's not suitable to choose 1 blade for wind turbine because due to its stability. Same goes with 2 blades. It will wobble when they turn to face the wind, so it becomes steadily less effective. The greater number than 3 blades would create a greater wind resistance, so it will slow down the generation of the electricity. Thus, it's becoming less efficient tools, and also it costs more because to produce more blade. So that is why 3 blades are ideal compromise between high energy yield and durability of the turbine itself. As for the conclusion, at end of our research on this topic, 3D drawing model of wind turbine are able to be presented using CATIA. Next, our group members are able to understand the flow system of the wind turbine and the work system of the wind turbine. Besides, comparison between traditional with designated wind turbine has been identified. Furthermore, advantages and improvements in the designated wind turbine are stated. Last but not least, our group are able to explain how the wind turbine are working. Overall, the objective of our group project has been achieved successfully. Thank you.